All right, so 1.3a, the I can statement is I can solve inequalities. So an inequality is similar to an equation, but differs in the fact that while an equation has one value that makes it true, an inequality has infinite values that make it true. So for example, when we had an equation, x equals 3, there was only one value that makes that true, and that's 3. Now that we have inequalities, x being greater than 3, there are infinite values that can make this true because there are infinite numbers that are greater than 3. 4, 5, 6, 7, 8. I could sit here and list infinite numbers that work for this inequality. So that's one of the main differences. We'll see some more differences as we move along here. So to graph inequalities, the graph of an inequality is going to show the values on the number line that represent the solution to the inequality. So the last example I just gave with x is greater than 3, it would show on the number line all the points or all the numbers that are greater than 3. So when graphing an inequality, we use open and closed circles to indicate if a value is a solution of note. And so that means, is it a solution or not? So if we give an open circle, which will look like that, that means the value is not a solution. So when I was saying x is greater than 3, 3 wouldn't be a solution to that because 3 is not greater than 3. So I would put an open circle. When we put a closed circle, it tells us the value is a solution. So that would be like me saying x is greater than or equal to 3 because the symbol equal to includes 3 in the solution. So if we had x is greater than 3, it would be an open circle. Same thing if we had x is less than 3. So if our inequality symbol is just a plain greater than or less than, it's going to be an open circle. If it's greater than or equal to, or if it had been less than or equal to, then it will be a closed circle. So it's the equal to symbol that closes the circle. So for this graph, we have a closed circle and the values are greater than -1. So we would say that x is greater than or equal to -1. So this graph and this inequality match. Here it's an open circle and it's smaller than 2, so x is less than 2. Notice I don't put the line underneath because of the open circle. So that's how we graph our inequalities. So if I were to graph -3, x is less than or equal to -3, I'm going to put -3 on my number line. I'm going to go one value below and one value above. Because of the line, I'm going to put a closed circle on -3, and I read this as x is less than or equal to -3. So the numbers that are smaller than or equal to -3 are on this side of the number line. -2 wouldn't work because -2 is not less than or equal to -3. That's not a true statement. So when they write it like this, sometimes people find it more helpful to have the x on the other side of the inequality symbol, like flipped around. So 4 is less than x is the same as saying x is greater than 4. So if you want to swap the sides, you also need to change the direction of the symbol. So I changed x and 4, so I have to change the inequality from less than to greater than. So now if I'm graphing this, I'm going to put 4, I'm going to go one below and one above 4. It's just greater than, so it's open circle because 4 is not a solution here. And the bigger numbers are on this side of the number line. So that's how we graph that inequality. So now we're going to solve the inequalities algebraically. And so when we solved equations algebraically, we used POE, P-O-E. Here we're using poise, P-O-I. And these are properties of inequalities. So we have the addition, subtraction, multiplication, and division properties, apoi, spoi, mpoi, dpoi, with one major difference, and this is so important. The difference is that if we multiply or divide by a negative number, we have to flip the inequality symbol. So for instance, if I had negative 3x is greater than 12, to get x alone, I'd have to divide by negative 3. Dividing by a negative means that to keep it an equivalent inequality, I have to flip the inequality symbol around. So I go from greater than to less than. And just a quick illustration of why we do that. So I think we can all agree 4 is less than 6. However, if I were to multiply by negative 2 on both sides of my inequality, I would get negative 8 on one side and negative 12 on the other. If I were to leave this as less than, this is no longer a true statement. Negative 8 is not less than negative 12. So to continue the inequality being preserved, I need to flip it to greater than. So multiplying by negative 2 told me I had to flip the inequality symbol to keep it equivalent on both sides. So anytime you divide or multiply by a negative, you have to flip the inequality symbol. So let's do some examples. So the first one we have is negative 3 times 2x plus 1 is greater than 10. That's our statement, and our justification is it was given. The first thing we do is the same as when we were solving. We're going to distribute the negative 3, and the justification is the distributive property. Now I need to add 3 to both sides. That gives me negative 6x is greater than 13. The justification was a poi with an I for inequality. Then I'm going to divide by negative 6. And dpoi says that if I'm going to divide, then I have to flip the inequality symbol from greater than to less than. And 13 over negative 6, that's just the fraction negative 13/6. So to graph that, I'm going to go and put negative 13/6 on the line. I'm going to go one below. One below is negative 14/6, which is negative 7/3. And one above is negative 12/6, which is negative 2. So I literally go 1/6 below, 1/6 above when I'm graphing it, and I just I simplify the fraction. So since it's less than, open circle, and the smaller numbers are on this side of the inequality symbol or of the number line. So for the next one, I've got my given. So 4x plus 7x minus 10 less than or equal to 15. My justification is that was given. I'm going to combine my like terms. So I get 11x minus 10 is less than or equal to 15. The justification there is combining like terms. I've got to isolate the x, so I'm going to add 10 to both sides. That gives me 11x is less than or equal to 25. That was a poi. And then I'm going to divide both sides by 11. I'm not dividing by a negative, so I keep the inequality symbol facing the same way. Dpoi only says switch the symbol if we divide by a negative. So I will put 25 over 11 on my number line. I'm going to go one below, that's 24/11ths, and one above, 26/11ths. I can't simplify them like I could over here. Remember, this was negative 14/6 and negative 12/6, so I simplified them. So here I can't, so I'm just going to leave it. I'm going to do a closed circle because of the equal to, and it's less than, so the smaller numbers are on this portion of the number line. So now we have to talk about the number of solutions that an inequality is going to have. So most inequalities have infinite number of solutions. For example, x is greater than 3 had infinite solutions because there's infinite numbers larger than 3. However, there are going to be two special cases for the number of solutions. The first is that there could be no solutions. If I had 4x plus 8 is less than 4x plus 2, if I were to go to solve this, I'd have to subtract 4x from both sides, which would leave me with 8 is less than 2. That's a false statement, so I have no solutions here. This is going to be an impossible scenario because it's impossible for 8 to be less than 2, so there's no solutions. So basically, I'm looking for a false statement. If I get a false statement, there will be no solutions. There will be all real numbers if I'm left with a true statement. So let's take the same one that we just did. 4x plus 8 is greater than 4x plus 2, and just flip the inequality symbol. By flipping the inequality symbol, the x's cancel, but now I'm left with 8 greater than 2, which is always true. So every single number for x is a solution to this inequality. No matter what number I plug in for x, I am going to get infinite, or I'm going to get a true statement, so every number is a solution. So let's just check these ones out. So we should simplify before we decide. So I'm going to distribute, and I get 5x plus 30 minus 2x is greater than 3x plus 8. I'm going to combine my like terms, so I get 3x plus 30 is greater than 3x plus 8. I'm going to subtract 3x from both sides, and I get 30 is greater than 8. Since this is true, I know that all real numbers are a solution here. Every single value of x will give me a true statement. So all real numbers are my answer. All right, same thing here. Let's start by distributing. So 10x minus 3 plus 7x is less than or equal to 14x minus 10 plus 3x plus 7. Then I'm going to combine my like terms. So 17x minus 3 is less than or equal to 17x, and then negative 10 and 7 make negative 3. If I subtract 17x, I'm left with the statement negative 3 is less than or equal to negative 3. Because of the equal to symbol, this is true. Negative 3 is less than or equal to negative 3. So since this is true, it's another all real numbers. If it had been negative 3 less than negative 3, that's not true because there's no equal to symbol. That would be no solutions. So this equal to made it all real numbers.